Hello, my Wobblies. I made a mistake earlier because I was trying to talk about too many things, and so then I have to start over, but I realized I didn't make another copy, so I'm going to end up just talking about it. You're going to end up seeing my mistake anyway, because it was this right here is what I did, and I was so mad at myself. Okay, so you know what happened was that I told you that there was already a video from last year for this quiz practice, and it turns out that last year I decided to do the practice quiz for number 2, and I almost always give you practice quiz number 3, so that's what I sent out this year, and now I have to make you a new video. That's okay. I already started, but I made a little mistake along the way, and now I'm restarting, and I don't have another copy, so we're going to use this copy. We'll be okay. Let's look at the first one. I should have just explained it in the old video instead of starting over. But 58 hundredths, we are estimating, it says right here, and we have answer choices. So we know that all of our answers are going to be digits of 2 and zeros and a decimal in some sort of order. But the real science right now, and it is science, is keeping track of our decimal and proving that we know how to be responsible with our decimals and where to put them. So, I think I need to make some sort of motto about taking care of your decimals. Tuck in your decimals, dot your decimals, demand decimals. I don't know what. Hey, the dog's home. Okay. 58 hundredths is going to round to 6/10. We have 6/10 divided by 30. And that's really okay because I'm allowed to have a decimal in my dividend. Remember, the dividend is down here. He's in the dend. Our divisor is here. He's under the visor. And the queen is the quotient, and she's up in the attic. Why do we put the queen in the attic? I don't know. But she's got some peace and quiet up there, and I hope she's happy. It is perfectly okay to have a decimal in the dividend. We don't need to do anything with this fraction because the decimal just comes up. And how many times does 30 fit into 60? Well, the 30 doesn't fit into the 6, so I put a nice 0 there, keep track of that. But the 30 does fit into the 60 2 times. 2 times 30 would be 60. I subtract, it's a 0. I'm sorry I didn't do that for you. I hope you believe me. 2 hundredths is the correct answer. Let's look at the second one. See, I started to make a couple mistakes here because I almost started calling that 6 tenths again, but this one is now 6 wholes divided by 3 hundredths. Now, this is the thing that's not allowed because we cannot have this number with a decimal. So what am I going to do? Now, that's exactly where I made the mistake that I just caught, that I like to just multiply by 100 because multiplying the top and the bottom by the same number is usually how we make it, equivalent fractions. And we know, because I proved it to you with all sorts of nice examples of dividing, let's see, what was it? 7/9 or 14/18. And although the math down below, I think this is called the victrum, or it's something like that. I'm going to look that up. But in the long division, all the numbers down here were different. My quotient added up to be the same. It was 0.77777777777 and on forever, which is another good example of why we sometimes keep numbers as fractions. So we usually multiply the top and the bottom. Now the book keeps, instead of multiplying by 100 to get rid of decimals, they like to divide by, and this is by 100th. And I accidentally put 1/10, which is not the same thing. Now, why they do this, I don't have a very good excuse. Dividing by, technically 1/10 is also written as 1/10. So dividing by a dividing kind of equals multiplying. It's like a double negative. So why we have to do it this way, I don't really know. The book keeps doing it this way. I don't want to confuse you, so I'm going to talk about the fact that that's the way it happens. But I'm also going to then just be stubborn and do it the way that makes more sense and that we're more familiar with, because I'm hoping that will stick in your brainy brain because you got brainsy brains. This is multiplying whatever we do to the top, we got to do to the bottom, and it makes an equivalent fraction. We haven't changed how big my whole is. We haven't changed how much of the whole I have. We're just making a lot more different parts. Right? We understand that because just to reiterate, you know that this is 1/3 Well, this is 2/6. Did I change how much I actually shaded in? No. I just drew a line down the middle and broke it into more pieces. That's all we're doing here. We're multiplying the top and the bottom by 100, which is now going to get us that 6 wholes. B times 100 becomes 600, and that 300ths now just becomes a 3. 600 divided by 3. The 3 fits into the 6. 2 times 3 is 6. We get a 0. Those other zeros come down. Nothing's going to happen to them because 3 doesn't fit into 0 and 3 doesn't fit into 0. So those just stay as zeros. We've got an answer of 200. Booyah. There it is. Next one. 58 wholes rounds to a 60 divided by 300. Also, perfectly okay. No decimals in sight until I create them because 300 doesn't fit into 60. 300 doesn't fit into 6, so I put a 0 there. 300 doesn't fit into 6D, so I still put a 0 there. The decimal moves up. Does 300 fit into 600? Yes, it does 2 times. Now, just for fun, what if let's go back up here. Woo-hoo! Making a little arrow. What if we took off those zeros for just a second and then modified our decimal at the end to compensate for that? Because we're allowed to do that. What if I knew that these are 2 zeros and I just take them off? Then it's 60 divided by 3, right? How many times? It's going to be 20. But how many decimal places did I have to account for? That's 2, right? So I need to take those 2 back out. Booyah. My decimal just moved from over here. Boop, boop. And it stops there. Either way, I end up with 2/10. And 2/10 is the answer. Okay. Last one of these. 58 hundredths rounds to 6/10 divided by 3/10. Not allowed to do this. And this is where I discovered that I had written 1/10 over there instead of dividing by 100th, because I was about to talk about it over here and I said, whoops. Okay. Once again, I would really just prefer to multiply by 10 on the top and the bottom, but you can also call this dividing by 1/10 or dividing by 1/10 or dividing by 1/10, written like that. Any which way that you do it, as long as you do the same thing, dividing or multiplying to the top and the bottom, we end up with an equivalent fraction, and then we're allowed to answer it. So I am going to end up with 6 divided by 3, which I really hope you don't even need to turn into a long division problem, because this is just it's not improper. It is not indecent. Gordon the train cannot say it's not proper, it's not decent. It's just a fraction greater than a whole. How many times does 3 fit into 6? 2. 2. That's it. Okay. Now we actually get to do some math instead of just keeping track of decimals all the time. 89 6/10 divided by 400. 89 6/10. Now, we could do this one both ways. I could leave it as 400 and then figure that 400 is not going to fit into 89 and we're going to have to make all sorts of zeros. But how about I just knock off those zeros for just a second and then divide my answer by that 100 at the end to get out the decimal again, right? Let's see. How many times does 4 fit into 8? 2. 2 times 4 is 8. We end up with a 0. We take down the 9. Doop, doop, doop. There it goes. How many times does 2 fit into 9? 4 fit into 9 is also going to be 2 times 8. We end up with a 1 left over. Now that 6 comes down. How many times does 4 fit into 6? Is 4 times. 4 times 4. Okay? Now, technically, my decimal was just here, but I have to compensate for the 2 zeros I did not divide out. So I'm going to divide those out now. And how do I divide out 2 zeros? Bloop, bloop. Move my decimal point 2 places. Booyah. Okay. Just for funsies, because kind of it is. What if I left it as 400? I can do this. 400 doesn't fit into 89. It doesn't fit into 8. It doesn't fit into 9. The decimal moves up. How many times does 400 fit into 80? Well, 896 now is going to be 2, and that's going to be 800. Feels more like partial quotients with all these zeros flying around, right? And then I end up with a 96, which also does not fit in. 400 does not fit into, so I'd create a 0. How many times does 400 fit into 960 is also going to be 2, because that's 800, which is going to leave us with 160. 1 0, 1 0. And how many times does... Oh, hold on. Did I create it? Let me think about that just for a second. It is... Oh, I have to create an... That's the whole problem. Bloop. I need to create another 0 so I can cross that out. There we go. 2 zeros. I forgot about creating this 0. I was like, wait a second. Where did that go? And that's going to be a full-on 4. Now that makes sense because 4 times 400 would be 4 times 4 is 16. Put those 2 zeros back on. Blah, blah, blah. Right? Okay. So it works both ways. I proved it. That's too much math. It's over there. Let's do this one over here. Bloop. Now I have 4 5/10 divided by... Can I just divide it by 6 and then put my 0 back on afterwards? Is that okay for you after? Because that just means that my decimal is going to be here, but I'm going to move it over 1 to compensate for the fact that I did not have a 0 there. I can prove it both ways again if you insist. But I really prefer to just think 6 into 45 is going to be 7, because I know that that's going to be 42, and I'd end up with a 3. I'd create a 0. How many times does 6 fit into 30 is going to be 5. And technically my 0 was here, but I need to compensate for that 0 I did not divide out. So I'm going to plop my decimal over there and add a 0. If you really, really, really insist that I do 450 divided by 6D, see, the problem with this one is I don't actually know my 60s times table. I would figure that 5 times 1, 2, oh no, hold on. 9 times 50 is going to equal 450. So I know it's going to be up there. 8 is already too close because those are going to add up. So I really do think it's going to be 7 anyway. And you know what I'd end up doing is I'd put my 7 here. Hold on. Not my 7 there, because 60 doesn't fit into 45. So I need a 0 there. But it does fit into 450. It is going to be 7, because what I'm going to think about is 7 times 6 is 42, and then put that 0 back on, multiply it by 10. 3, 0, 0. And I know that multiplying by 5 cuts everything in half, but adds a place value. 5 times 6 is 30, is 3. So that 5 times 60 is going to be 30 plus an extra decimal place, which is 300. We can also look at the 5 times table as I like to cut it in half and then move a decimal place, because that's how I noticed it at first. But you can also figure that it's the same as 60 times 10 and then divide it in half, which would make sense, right? And 60 times 10 would be 600. What is half of 600 is 300. So that's equals 600. You can just cut that in half because 60 times 5 equals 300. I usually think about it as just cutting this number in half and then adding a place value. But it's all about what you noticed first, what's in your brain. And now we have 6 5/10 divided by 5. And this is okay because the decimal's right here. We're allowed to have it there. Whoopsie, you're not looking at it. 1 times 5 is 5. I get a 1 left over. This 5 comes down. It's 15. That's going to be a 3. And now 3 times 5 is 15. I end up with nothing left over, and that is fine. So this was... both of those work out. Now this one, Lacey has 9 2/10 meters of rope. She cuts the rope into 5 pieces of equal length. How many meters long is each piece of rope? This actually just choose the expression. And I honestly, the first time I looked at this, I almost started answering it and then realized, oh, whoopsie dipsy. It really just wants an expression. What's being broken up here? The meters of rope into pieces of equal length. That's division. 9.2, 9 2/10 divided by 5. 9 2/10 divided by 5. That's the one. Boom. All done. Turn to page. Whoopsie. Not that page because I printed it out one-sided. We got a little bit of math to do here. We can do these. Okay. I'm going to start way up here so we have some extra room. 42 divided by... Now, this is the part that's not allowed because if I put this under the visor, that's not allowed. So how will I get rid of that? Times 100 or dividing by 100th. Either way that you look at it, I like to times by 100. I like to times by 100. I like to not divide by tenths. Why would you double divide? I need to write the song before I tried singing it. 4200 and 7/100 times 100 is just going to be 7. 4200 divided by 7 is perfectly allowed. Does 7 fit into 4? No. Does 7 fit into 42? Yes. How many times? 6 times. It equals 42. I end up with a remainder of 0. These other zeros are just going to come down, and I know I can't do anything with them, so it's going to be 0 and a 0. I don't need this one anymore. My answer is 600. I like to put it there, though, just to remind you. It's very important to keep our 6 above the 2 because that's the place value that the 7 fit into. It infers, to use our reading term, that there's a 0 over there, but sometimes there might be a decimal over there, and then you need to write the 0. Oh-de-doo-de-doo. I have 11 2/10 divided by 14/10. Again, not allowed. No good. Sratave. I'm going to multiply by 100 because that's what I dig. That's going to equal 1120. I just moved 2 places. The 2 is still there, but then I have to add 1 0. And this moves my decimal place 2 points. So I end up with a 14. 1120 divided by 14 is allowed. Now, 14 does not fit into 1. 14 does not fit into 11. 14 is going to fit into 112. I know it's not going to be 10 times because that would be 140. Hold on. Yes. I can guess that it's not going to be 9 times because that's also a little bit too close. I'm actually going to think to myself, I could do 14 times 8 and test it that way. And actually, yeah, that is what I'm going to do because cutting in half and doubling doesn't really work either because I don't know my 16 times table multiplied by 7. 8 times 4 is going to be 32. So I carry the 3. 1 times 8 is 8 plus the 3. Whoa, that worked. I'm going to put an 8 there. 8 times 14 equals 112. I end up with a 0. This 0 comes down. Does the 14 fit into zeros? No. So I need another 0. These don't matter. 80 is my answer. Last one. I have 55/100 divided by 44/100. Not allowed. Multiply the top and the bottom by 100. That gets me a nice, pretty 55 divided by 44, which is allowed. 55, 44. The 44 does not fit into 5. It fits into the 55 once. 1 times 44 is 44, which ends up with a 1. Right? Am I done? I could do a remainder of 11. I could do 11 out of 44 as a remainder, but we're not doing that anymore. We're creating decimals and adding zeros. So let's bring down that 0. and put that there. How many times does 44 fit into 110? I'm going to say 2 because that's going to be 88, and I can tell in my brainy brain that there's not going to be more room after that. 88. But let's double check it because it's going to happen anyway. This is going to become a 0. I don't even have to regroup because that 10 is already there. And this becomes a 10. That's a 2. 22. Does my 44 fit into 22? No. That was a good job. Now I create another 0. I bring it down. How many times does 44 fit into 22? This is when your multiplying by 5 trick is handy again, isn't it? Because I could think 5 times 44 is going to equal what is half of 44 is 22, and add another place value, 0. Or 44 times 10 is 440, and then divide that in half is also 220. You can think of it either way, but it proves that this is a 5. 5 times 44 is 220. I have no remainder. We're all done. 1 and 25 cents. 1 1/4, actually. 1 1/4 is the same. Toby and Scott each have 28 and 1/4. I'm sorry, not 1/4. 4/10 kilograms. Ooh la la la. Trying to say kilometers. Kilograms. Okay. Let's give Mrs. Sepko her coffee, huh? Ooh, yeah. This is spilling the tea since 1773. This is my coffee cup from Boston. Oh, okay. Toby uses clay to make vases. Each vase, or vase, uses 1 3/10 kilograms of clay. How many vases can Toby make? Okay, I'm going to divide. And once again, I'm going to draw this as my fraction real quick first to show you. I'm not allowed to have a fraction down here, so I'm going to multiply by 10, or divide by 1/10, whatever you want to call that, as long as you do the same thing to the top and the bottom. And I'm going to end up with 284 divided by 13. And does 13 fit into 2? No. Does 13 fit into 28? Yes. 2 times, because that's going to end up as 26. I'm going to have a 2 left over. This 4 is going to come down. Does 13 fit into 24? Yes, but only 1 time. I will tell you, this is actually let's put a line right there. We don't need to confuse that. We actually don't need to go any further than this because 1 times 13, I am going to end up with a decimal, but I can't make part of a vase. So I don't need a decimal. I don't need to know that he can make, 21 and blah, 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 thirds or 14ths of another vase. He's not going to make a 14th of a vase or whatever it is. So I'm done. 21 vases is the answer. I only need to know how many whole vases, not parts of a vase. So 1 times 13, I end up with a 1 and a 1, which is less than 13. I do not have enough to make another vase. That's all I need to know. That's a line from Les Mis, in case you really wanted to keep track of the songs that are in my head. How many kilograms of clay does Toby have left over? Okie dokie. Now, if he makes 21 vases and each one uses 1 3/10, that's multiplication. 3 times 1 is 3. 3 times 2 is 6. Happy 0. Happy. 1 times 1 is 1. 1 times 2 is 2. Add them together. 3, 7, 2. Now, there's 1 decimal place in my equation. So there's 1 decimal place in my answer. He used 27 3/10. How much did he have to start with? 28 4/10. 27 3/10. Now I can honestly just see this, but if I take how much he started with, right there, and subtract how much he used, make sure you line up your decimals because we have to have our place value. I can't take away tenths from whole ones or from tens. That would be ridiculous. 4 minus 3 is 1. 8 minus 7 is 1. 2 minus 2 is 0. And my decimal point just stays there. 1 1/10 is the answer. Scott uses his clay, he's a wild, crazy guy, to make 16 equal-sized lamps. Note that it says equal-sized because dividing means breaking into equal groups because they're fractions. And aren't fractions always same size pieces? Yes, they are. So, how many kilograms of clay does Scott use? Excuse me. Does Scott use to make his 16 lamps? Well, I'm going to take 28 4/10 amount of clay and divide that by 16. I don't need to take out any decimals because I have a whole number over here. How many times does 16 fit into 28 is just going to be one time. 1 times 16 is 16. I subtract, I end up with a 1, 2. 16 does not fit into 12, so that was a good job. Good job, Mrs. Hepko. How many times does 16 fit into 124? Again, a tricky one, because I don't know my 16 times table. I know that 10 times 16 would be 160. If 160 minus 16, I already can't think of that. There would be a 4 and a 1. 44? 144? I can't think about that right now. But that also, 9 seems like too much. I'm going to do 16 times 7. 7 times 6 is a 2. 4, 1 times 7 is 7, plus the 4 is going to be 11. Oh, look at that. 1, 1, 2. That matches. I could also figure that instead of counting down from 10, I could count up from 5. That's actually probably easier, because 5 times 16 would be 80, half of 16, moving over a decimal. And then plus a 16 would be 80 plus 16 is 96. That's easier for me to understand. And then 96 plus a 16 would be 112. So that actually works. But this works too. There's always so many ways to doing something. And then I subtract 2, 1. And can 16 fit into 12? No. Oh, this decimal moves up. That was a 7. Remember this 7 over here. I'm going to create another 0, and I happen to know that it's going to be another 7 because that's going to be 1, 1, 2 again. And that's going to end up with just a plain old 8 because I happen to know the difference between 12 and 20 is counting up is 8. If you really needed me to make this a 1 and make that a 10, I could do it. And that, honestly, just a second ago, I mentioned that 5 times 16 was going to be 80. And that is my AD down there because I create another 0, right? So that works. He uses 1 775 thousandths kilograms of clay. That's the end.